Yep, so my name's Ren. I work here at Atlassian. Is this level of volume okay? Yep. So I thought I'd give this talk on optics because, as Michael mentioned, the two of us were going through some optics code in the Atlassian code base, and we got a bit confused, and so we did some research, we figured out some stuff, and I thought I could share some of what I learned. So the audience of this talk is for people who are new to Scala or new to functional programming, or if you know the term optics but you don't really know what it is, or if you just want a refresher. If you've already got a good understanding of optics, this is probably not going to teach you much, but hopefully you can learn something. So before we go into optics itself, let's talk about a scenario of a problem we want to solve. So assume that we have something that gives us this JSON. It can be like some REST API or some database call or something. Basically, you end up with some JSON. It's nested. You've got a user. That user has attributes. Those attributes are split up into two types. You've got personal attributes and security attributes. The personal attributes have, in this case, an email. The security attributes have things like verification settings and the type of second-factor authentication you have. So in this case, this user has email verification as his second factor, but it might be SMS verification, it might be something else. So kind of a standard little bit of JSON that you could get in your job. And we could represent this in our Scala code with a bunch of case classes. We want to use types, obviously. So we have like a type representing the user, type representing the attributes. We have a case class wrapping the email type. And then we have a trait a little bit down the bottom there that's called second factor and has the types of things that could extend it. So you could have no second factor or SMS or phone numbers. So we could imagine translating this JSON into that list of case classes pretty easily. Now, assume we have an objective, a business case to implement a function like this, which is we've got a function, takes in a user, same type of user that we saw earlier, and an email of some other email type, as in different to the email address we have here, but basically containing the same information. And the goal for this function is to return a user where the email is changed to the one we've been given, and if the user had email verification as the second factor, to set it to disable it, to set it to off. This is like it's a thing that we'd probably be doing something like this in our day-to-day job quite often. So how would we do this? Well, okay. We had bars in our case classes, so we can just mutate everything. So we take our user, we set the attributes.personalattributes.email to the new email address. We check what the value is on the user.attributes.security attributes.verification settings.second We see if it's email verification, and then we set it to no second factor. Otherwise, we keep things the same. Then we return that user. So that's pretty simple. But we use a whole bunch of vars there, which is kind of bad, right? Because it means our code is mutable, it's harder to reason about, it's not as thread safe. It's generally a bad idea for many, many reasons. So let's try and fix that up. Let's get rid of all the vars. So we have the same case class definitions as we did before, except now they're all immutable. Okay, that's better. And let's try to solve that same problem. So now, we can't just mutate stuff in place. So let's say we use the copy function. If you're not familiar with that in Scala, if you define a case class, you also get a copy function, which allows you to modify that and return a new copy of whatever it is that case class is. So because everything is nested, it's not that easy. So we have to call user.copy, and then we set the attributes on that user to the user.attributes, except we copy that, and then we set the personal attributes on that to user.attributes.personalattributes, and we copy that. And finally, we change the email to the new type. Store that in a val, and we do the same thing here, where we have email changed on user.copy, set the attributes to email change on user.attributes.copy, set the security attributes to email unchanged, .attributes.security attributes.copy, email change on user attributes security attributes verification settings.copy, and so on. This is kind of a pain. And also, if you look carefully, that's the wrong user that I've passed in here, which doesn't actually cause an issue here, but could easily cause an issue if we were relying on something that we changed up here. So that's a bug that's easy to miss, easy to write, and maybe you'll pick it up in tests, but maybe you won't. So yeah, that was kind of annoying. So let's think about what we're actually doing there. What's happening on our copy method? What we're doing is we're taking an instance of that user, we're taking an instance of attributes, and we're getting back another instance of user. And if we wanted to, we could take that user and get the instance of attributes from it. And it's the same thing with the attributes.copy. We're taking an instance of the attributes and an instance of personal attributes or security attributes, whatever it is, and getting another instance of attributes with that set on it. And in both cases, you can get the attributes from your personal attributes. So, sorry, you can get your personal attributes from your attributes. So if we generalize that concept, we could say, given an A, we could get a B, as in, given a user, we could get its attributes. And we could also say, if you combine a B and an A, you combine a user with its attributes, we could get another user. And this relationship is essentially what a lens is. It also needs to follow some laws, like the B plus, if you call the set, then when you get it back, it should be the value that you just set. But we won't go into laws into too much detail. So, okay, we call that a lens relationship. Who cares? So there's a library for Scala called Monocle, which helps you generate these lenses automatically on your case classes. You could write them by hand if you want, but it's handy to skip some steps. So if you had defined your case class as case class user attributes, and you put the @lenses annotation in, it generates a helper on the user object called attributes, which is a lens from user to attributes. Okay, and that lens gives you the methods we essentially talked about earlier. A get, which gives you attributes from a user, a set, which takes attributes, gets a user, and a modify, which is just basically doing both of those, as in getting something, using it, and setting it.
Sorry. The type of modify is given an attributes, and like what's the type of modify again?
Given an attribute, like it will give you you give it a function that takes an attribute to a user. Yeah. So it's the attributes from the user.
That's right. Cool. Thanks.
Yeah. So as Jed was spoiling for the audience earlier, the good thing about lenses is that they're composable. So if you have a lens from A to B and a lens from B to C, you can compose it together and get a lens from A to C. So when we were talking about our two lenses earlier, from user to attributes and attributes to personal attributes, we could combine them together and get a lens from user to personal attributes, which means we could do things like a get on this lens with a user and get personal attributes, and we could set personal attributes on the user directly. So let's try throwing lenses everywhere, tossing this annotation all over the place. And that should generate a bunch of helper things for us. And let's try and use them. So this looks a little complex, but let's step through it. So this is our first lens. This is a lens from a user to attributes. This is our second lens from attributes to security attributes. Third lens from security attributes to verification settings. And finally, from verification settings to second factor. So we end up with a lens from user to second factor, which is one of the attributes that we care about. We've defined another lens here from user to another email type, composing a bunch of lenses and also composing an ISO, which we'll get to soon. So by putting these lenses together, we can now just say, okay, using my lens from user to email, I'm going to give it an email and a user, and I'll get a user with that email changed. Using my lens from user to second factor, I can call modify, get my the current user's second factor, pattern match on it, and return a modified version. The result of this is a user with whatever we've set here on it. So Whether this is actually better, I guess, is debatable. It depends on your point of view. But the nice thing about this is that it scales linearly. So the more nested our code was, the more annoying that first mutation was going to be. But here it's just another thing that we compose. It's also much more reusable. We could combine these lenses in every way, and use them as we need to. And it ends up kind of separating your logic a little bit from what you want to access to what you want to do with it, rather than kind of combining it together. So it was a lens, but there are more of them. So we saw that we had this function compose ISO. Lenses are actually part of a family of things that we call optics. So there are, I'm going to talk about 4 of these optics. There are a few others, but these are kind of probably the main simple ones. If we kind of think of them in terms of strength, and I'll explain what strength is in a little bit, we have the strongest optic, which is the isomorphism. We have 2 weaker ones, kind of equivalent in strength, called the lens and the prism. And we have the weakest one called the optional. And the definition of an isomorphism is essentially equivalence. So whereas with our lens, we had to take an A plus a B to get an A, here, if we have an A, we can get a B. If we have a B, we can get an A. And an example of this would be our 2 email types. So assume email address contains a raw value as a string, and there's another email address type which contains a value as a string. If we define how we swap between those 2, as in how to go from email address to another email address and how to come back, that relationship is an ISO, and we can create it this way. This is using Monocle. It's the strongest relationship. It's probably not that useful, at least that I've seen. But if we then look at some more relationships, we've got the lens, and that's a weaker relationship, and it's weaker on the setter side. So we look at our 2 relationships there. We've got to add, we can't just get an A from a B, we need to have another A to combine it with. And on the other side, we've got the prism, and in the prism, it's weaker on the getter side. So what we say here is, given an A, you might be able to get a B from it, but given a B, you will definitely be able to build an A from it. And as an example of that, if we look at this type alias, which is a result is either an error or a success, but not both, you could say that there's a prism from result to success, as in, if you have a result, you may not get a success, because it might contain an error, but if you have a success, you can build up an either with that success on the right-hand side. And the third, or 4th type, is the optional. And the optional optic takes the weaker getter from the prism and the weaker setter from the lens. So given an A, you might get a B, but to get an A, you need a B plus an A. An example of this would be, say you had a case class, and that case class has a bunch of attributes. One of those attributes is an optional attribute called middle name. Person to middle name is an optional, because given a person, you may not get a middle name, and given a middle name, it's not enough to build a person from it. You need another instance of person to build on top of it. So the interesting thing about these is that all these optics compose not just with each other, but with the other types too. And the result of the composition is the weakest common type. For example, if we look at the hierarchy, if you combine a lens with an isomorphism, you'll get another lens. If you combine a lens with a prism, there is no common type there, so what you'll end up with is an optional. Combine an optional with a prism, you'll get an optional. Yeah, so if we look back at that ISO that we saw in the first example, essentially what we had built here is a lens from user to email address. And then we've composed an ISO, which we've built here, from email address, our first email address type to our other email address type. And that becomes a lens from user to that other email address type. Yeah, so whether it's actually useful, kind of discussed that. There's advantages in that it's an easier and more reliable way to work with immutable data structures. You're less likely to have errors with it. Results in reusable code, which is always an advantage. Disadvantages are that you do need to pull in another library to use something like this. I mean, you could kind of hand code these, I suppose, but it helps. And while we could generate the relationships on the case classes for lenses, not all of them can be generated, and some of them you have to kind of explain how to get from one state to the other, which requires more coding. That's pretty much it for the talk. Some extra reading I'd recommend if you're interested in this is to check out the Monocle documentation. It goes, basically I paraphrase the documentation. It goes through all of this stuff. It also talks about the other types of optics you can have, like traversals, folds, setters, and getters. And also talks about the laws. So we briefly touched on laws, but essentially the relationship has to follow certain behavior in order to actually be an optic. Yeah, and that's about it. Thank you.
Good stuff. Questions? You have just a tick.
Thank you for the talk, and it's very good. I think I should have used this one a long time ago. But yeah, so in practice, like how many times do you type copy before you actually think that you should start to use lens?
Well, if you generate your lenses at the start, you would just never use copy because you have all these little tools that you could just kind of throw together. But I'd say in practice, maybe 2, 3 levels where it starts becoming useful.
Or at least where people start complaining and you start looking for alternatives. Yeah, that's a good question.
This one.
Right.
I'm not sure if you answered this one. I haven't used much Scala, but I noticed the @lens notation.
Mm-hmm.
Can you, to someone that hasn't used Scala, can you explain how that how would you do that yourself? I want to make an @Clinton.
You want to build a macro.
How does that magic work?
I don't know. I'm not the best person to explain that. It's a macro, and there is, I don't know, Jed, do you have a better idea?
Yeah, it is going into macros, which are compile time things. I'm not entirely certain how the lenses macro, like how annotation-based macros work. But yeah, so it's macros, so it's doing like code generation, essentially. Yeah.
I think that'll have to be the topic of another talk.
Yeah, macros are kind of like crazy town place where you're not in typed kind of Kansas anymore, and it's you're dealing with like generating actual abstract syntax trees of Scala and hoping that it all type checks and so on. It's kind of fun for the kind of fun that like wearing a hair shirt.
Cool.
Anyone else? All right. Thanks, Ren. Legend. All right. We'll be back in about 5-10 minutes.